Hello, let's solve this drug monopoly problem. We've got somebody who's a producer, they have a monopoly, curing some kind of disease. Here is the demand function. This has already been converted into an inverse demand function.
I get it, man.
Then total revenue is right here, which is just price times quantity, so that's why this looks like the same thing here. Marginal revenue has already been solved for us. It's the partial derivative with respect to Q of this function, or really it's the rate of change in total revenue as we produce more quantity, or rather sell more quantity. Total cost is just 4 times Q, so this is 4, monies, whatever the money is, in this environment for every drug that they produce. Then the marginal cost is just 4 because that's the change in total cost as we produce more units. So that's always going to be 4. So profit maximizing price and quantity. So that's going to be found by solving for where marginal cost equals marginal revenue. We have both of those formulas, so we're just going to set them equal to each other. So marginal cost is 4, and marginal revenue is 50 minus 2/3 Q. Okay, and so I'm just going to algebraically solve for Q. So I get 2/3 Q. I wonder how many times I say oops on these videos. 46. Okay, and then Q equals, I can just algebraically, I want to get rid of that, so I can just go 3 over 2 and multiply 3 over 2. So over here on this side, those are going to cancel, those are going to cancel, and switch back to black here. Now I'm going to get out the calculator because I'm not that good, and we're going to go 46 times 3 is 138, and then divided by 2 is 69, which is the profit maximizing quantity. Okay, so this is the amount of products that a single price monopolist or a firm that has a monopoly would want to produce. Okay, so then the price, okay, we want to mark up the price, so we're going to use this quantity, and we're going to, equals 50 minus 69 divided by 3. And so 69 divided by 3, oops, not that one. 69 divided by 3 is 23. 50 minus 23 is 27, so that's going to be our price. Okay, so profit maximizing price is 27. Quantity is 69. What is the profit? Okay, so there's a couple ways to do profit. The most straightforward way is to calculate total revenue minus total cost. So total revenue is going to be 27 times 69. And so with that, I already did that prior to recording this. So total revenue is 1863 minus total cost, which is going to be 69 times our 4. Okay, 4 is the marginal cost of producing each unit, and I already did that one too. And so on that one is 276. Again, I said whoops. 276, and so total profit is the difference between those two, and it's 1587. An alternative way to do that faster probably is to just calculate the per unit profit. So we're going to sell each unit for 27, and each unit costs us 4 to produce. So that's a per unit profit or marginal profit of 23, and then you could multiply that 23 by 69. You'll get the same answer. Okay, what is the efficient price? So the efficient price is going to be the supply and demand price that we're kind of used to. Okay, so for that one, we're just going to set marginal cost equal to our demand function here. So we'll draw a line right here. So this is going to be 4, which is the marginal cost, equals the demand function. Or really, inverse demand function. I'm going to solve for Q. So 50 minus Q, I don't know Q, divided by 3. And I'm going to multiply everything by 3 so that I get rid of that 3 right there. So minus 3, so that's 150. And then equals 12. Okay, so we'll send that over there. This is negative 138. And negative Q, so Q equals 138. Okay, so that's the quantity. And then when we're producing at that quantity in the demand function, that's just going to give us the price. So price is gonna also equal 4. Okay, and that's what we mean by efficient anyway. It means that the price equals marginal cost. Okay, so if it's like perfectly competitive. So that's the quantity and price output there. Calculate the deadweight loss associated with the monopoly. Okay, so this is the difference between this output and this output over here, the monopoly. Okay, where the price and quantity are that. So it's a linear triangle. What you could do is graph this, but we'll just calculate it. Deadweight loss. Okay, so it's 1/2, and it's the difference between the efficient price and the monopoly price. So I could write that out. I could write 27 minus 4, but I'm just going to write 23 times the difference between the monopoly quantity and the efficient quantity, which is 138 and 69, which happens to be 69 coincidentally. Okay, and I already did the math on this one. So it's 23 times 69, and then 1/2 of that, which is 793.5. Okay. Okay, so that's the deadweight loss. All right. Now, to regulate the monopoly, a tax of $1. What they mean is $1 per unit. So basically, you're going to redo this whole problem where marginal cost equals 5 rather than marginal cost equals 4. And just redo those steps, and you'll get the price, the new price, okay, and the new quantity. And if you want to go ahead and do it yourself, the answer is 27.5, and then the quantity is 67.5. Okay, make sure you know how to do that, but it's kind of an ugly 7 there. And then the deadweight loss, again, is the difference between the efficient outcome, where price is 5, and then whatever the efficient quantity is at that price. So the deadweight loss is 2,109.375. Okay, so I didn't actually solve that last part, but I told you how to do it. So there you go.